In the previous video, we looked at how NSLock can resolve race conditions while threading. In this video, we're going to take a look at asynchronous methods and how we can utilize closures as completion handlers to wait for operations to complete to perform tasks. When dealing with concurrent programming, we need to know how to utilize asynchronous methods as the needs arise. Asynchronous methods differ from traditional synchronous methods in that once they have completed their own computations, they don't simply return a value using a traditional return statement. Instead, they utilize a completion handler, which is simply a closure that gets passed in as a parameter. The completion handler allows us to defer the execution of an operation until the necessary operation is ready. At the end of the last section, we added Alamo Fire and SW Reveal View Controller to the Game of Life application. We're going to utilize Alamo Fire to call out to a server to send and receive messages. In doing so, we'll uncover some common concurrency issues that we'll address by utilizing asynchronous methods. Bear in mind that this course is about the Swift language and not about iOS development. I've gone ahead and made some necessary changes to the application to make the focus of this exercise more clear. Feel free to download the starter project files for this video at this video's resource page. In our main game application, we've implemented a simple counter. It counts the number of iterations in each round, as well as the number of cells remaining. Once the game is complete, or is determined to be complete by our application, our program will post our scores to the server. Then we'll use a table view to display our downloaded scores. So if we open up our project and build and run it, we see the game board that we built earlier in this course with a few additions. If we tap on our game board, we are immediately greeted with an alert that asks if we'd like to post our score to the scoreboard. This isn't right. Clearly, the alert should be waiting for our game to complete before asking if we'd like to post our scores. To address this, let's review the code that initialized our game so that we can isolate the problem. If we look at our ViewDidLoad in our view controller, we added a UI tap gesture recognizer that calls a method named startTimer that starts our NSTimer. Our NSTimer in turn calls a method named moment that gets called repeatedly, and each iteration progresses the evolution of our game. In our moment function, we see a call to life.evolve, and then immediately afterwards, a call to a method named endGame. Clearly, we don't want to end our game until life.evolve has reached a point of completion. So let's add a completion handler to our evolve method in our life class. We'll pass a function type which we'll name completion. This function will take an int representing the remaining cells and pass it back to our view controller. Next, we'll add some simple logic that will determine the end of the game. Since our game rarely sees numbers below 25, I'll just choose an arbitrary stopping point of about 10% of our cells. Of course, you can feel free to do whatever you like here. So, if livecells.count drops below 40, we'll trigger the end of our game and pass back our final score. Back in our view controller, let's modify our call to life.evolve to conform to our evolve's new method signature. We'll use trailing closure syntax and the word remaining as our values label. And our closure returns void. Now that our method call is valid, we'll simply move our call to endGame into our closure and pass our remaining value into it. Of course, we'll need to add self to our call to endGame since it's inside of a closure. And again, since we're referencing self inside of a closure, let's include weak self in to avoid potential strong reference cycles. Now, if we build our application and run our game, we see that the game waits until we get below the 40 cell remaining threshold before firing our call to endGame. Once the pop-up appears, we have the ability to post our usernames and scores to the leaderboard. In this video, we have implemented a completion handler solution for a common programming problem. In the next video, we'll look at how we can manage concurrency with NS Operation Queue.